Hey, hello. Let me share my screen first. Just a second. Well, as I already said, this is a comparison of Kafka and Pulsar. I'm going to try to do a gender comparison. So it's not about what is the best of both of them. It's more about the differences, when it makes sense to use one or another one. So hopefully we learn not only the differences, but also how they work under the hood, what is the architecture of both of them, what are the main problems you may expect when using Kafka or Pulsar. First of all, let me introduce myself. My name is Anton. I am principal software engineer working for New Relic. New Relic is an observability company. So basically, we are doing a lot of streaming, ingesting data like logs, metrics, events, distributed traces in our own database, and then allowing users to query or create alerts of that data. The dimensions of what the throughput we have to support every day is quite big, and that's the reason why I am so interested in Kafka and Pulsar. I have been working with streaming systems for years now. I have the opportunity to work as consultant for different companies too. Most of my career has been working with Kafka. I am right now the Kafka architect in New Relic, but I also have the opportunity to work with Pulsar and even with other systems in the past. So, well, I'm also very active in the Java community, organizing some Java user groups in my city, Coruña, northwest of Spain. Well, it's super exciting for me to be in the box this year. It will be much better to be there physically. I couldn't make it this year, but I for sure will do it next one. So hopefully that will be possible. I hope you enjoy this talk, even if you are on site or you are attending online. So let's cover first the basis. If you are not familiar with Kafka or Pulsar, and then we will go in deeper concepts. To do this, I'm going to use a whiteboard, so you can see here. I'm not very good drawing, but I think it will help explain some complex concepts. So what is Kafka? What is Pulsar? And when we are going to use Kafka Pulsar? It always starts with data. So we have an application. I'm going to call it producer, which is generating data all the time. We want to put that data in a place so other applications can use it. That place may be Kafka or Pulsar. They are the really good options to work with this type of data. Why? Because Kafka and Pulsar, when they receive data in streaming all the time, they store that data locally. So basically now we have that data, as you can think, in a database stored in Kafka or in Pulsar, and other applications can go to Kafka or to Pulsar and read that data. So we can have an application, which typically we call it consumer, application A, a totally different application, consumer B, and a third one, consumer C. So the data is going from our producers to Kafka Pulsar, and then from there to our consumers. So we can see here the data. What is interesting about the Kafka and Pulsar in comparison with other systems is the fact of the data being stored internally in Kafka and Pulsar. So the consumers can choose to read the data as long as it's available, but they also can go at some point and say, hey, Kafka, hey, Pulsar, give me all the data you have. And basically, those systems are going to read all the data from the disk and send it from the very beginning to that consumer. So that is called the ability to replay the log. So the ability to back in time to reprocess the data. If a consumer has a problem, there's a bug, or there was an outage, it can decide, okay, let's go to Kafka and Pulsar and let's start again from the very beginning, or at least from some point in the past of my data. This is something not easy to do when you work with message queues or other systems, because they tend to delay the data as soon as it's consumed. Kafka and Pulsar are different than that, and it's one of the benefits for both of them. The other benefit we have is Kafka and Pulsar allow to isolate consumers between them. And this is also very important feature for both systems. So if consumer A has problems, performance problems, it's slow consuming messages. Consumer B and consumer C don't need to notice that. They can work as usual, even if consumer A has problems. So we can insulate consumers thanks to Kafka and Pulsar. So that's also one of the benefits compared these technologies with others. The ability to make consumers independent one of another one. That's something you can do with message queues, but the implementation is much more tricky, and the operation of it tends to be worse. The performance tends to be worse. But Kafka and Pulsar are specifically designed for those particular cases. So as a summary, Kafka, Pulsar, both of them are oriented to the same use cases in streaming. And the main benefits compared with other services is the ability to store data internally, so it can be used later, and the ability to make consumers independent of each other, so they can consume at their own rate and they don't have to care about what other applications are doing with that data. So that's what they have in common. Let's now cover what is different between them. First of all, Kafka. Kafka has been open sourced by LinkedIn some years ago. It's a super mature project, and the level of adoption is really high. I really like to think in Kafka and something similar to Kubernetes, but for data. Basically, it's the standard de facto nowadays in streaming systems. It's used for not only for very modern and technology companies, but also for companies in other sectors like retail or whatever you may expect. It's there are a lot of people with experience in Kafka. It's used not only alone, but with other technologies, other platforms. In general, we can say it's a super mature project. Pulsar is a bit different. It was open sourced by Yahoo some years later, and the main goal of Pulsar was to fix or to solve some of the Kafka limitations. So it was a project developed from scratch to solve some of the things which were painful, and most of them are yet painful with Kafka. The adoption of Pulsar is much lower than Kafka. When I was drawing this slide, it was not very clear to me if it's just before the change or after it. Thinking about it is probably just right after it, because Pulsar is also used for some very big companies out there. So it's a safe bet. Pulsar is not going anywhere, but yet it's not close to Kafka in terms of adoption. And it's also true there are some new technologies coming in this space. So it's not clear what's going to happen in the next 4 or 5 years? What is going to be the second most popular project on this? It may be Pulsar, it may be other alternatives which are more compatible with Kafka, like Redmond. It may be something totally different, like Nuts.io. So right now we have this big player, which is Kafka, but there are more things coming. Pulsar is for sure the second most popular. It's also pretty similar, but that may change in the future. In a way, Pulsar is a safe bet. If you are interested in Pulsar and you think it's the right tool for the things you want to do, I'm pretty sure Pulsar is not going anywhere soon, and you can do it because there are very big companies sponsoring it, using it, and the community is super active. So let's go now with the differences. And to understand the differences, we need to go into Kafka first to understand how Kafka works under the hood and what are the main limitations of Kafka. So let me share the whiteboard again. So as we did before, we have our producer, which is going to send data to Kafka. But Kafka is a high available system, so it doesn't run only typically in one machine, it runs in more than one. These machines, these Kafka nodes, is what we call brokers. So let's assume in this case, as an example, we have 3 different brokers, broker 0, broker 2, and broker 3. And what we have is our producer is going to send data to all of them. So we are sending data to all of them. The reason for that is if we have a problem with the broker 1 or the broker 2, doesn't matter, our producers are going to be able to continually send the data to Kafka because broker 2 or the broker 3, the remaining brokers are still available. So that's the type of high availability we want to have. Of course, when we have more than one broker, this is a distributed system, and we need some kind of coordination with them. That coordination is provided by an external service, which is called Zookeeper. So I'm going to call it here. It's also a distributed system. So Zookeeper 1, Zookeeper 2, Zookeeper 3. It helps the brokers to decide what broker is the leader, called controller, all the things when new brokers are coming or new brokers are leaving to really make the system coordinate itself. Zookeeper is a different project. It can be used, it's used inside Kafka, but it's also used as a standalone service or in other projects. And this is an important concept because if you need to manage Kafka, you also need to manage Zookeeper, and there are different systems with different ways to be operated, and they require knowledge in both of them. Okay, so that's one of the things people usually don't like about Kafka is the fact of you need expertise in Kafka, but also expertise in a different system in Zookeeper. So we have our producers sending information to the broker, and internally in the broker, that data is stored in the disk in the broker. So each broker will have their own storage, and is going to put the messages in the storage. And there is a high-level concept called partitions. So basically, partitions you can thinking like a file where we put all the messages arriving. So we have, for example, this partition 0, and Kafka writes the messages in the partition in the order they are arriving. And that's the same with the next broker. So partition 1 for the messages, and partition 2 with more messages arriving. And now we have our consumers. So we may have just one application, but with different instances. It's a high available application. So we have application A, and the instance 1 is going to read from this partition. The same with the second instance of this application. So application AI instance 2 is going to read messages from this partition, and the third one is the same thing. Application 3. The thing with partitions, they are basically the unit of parallelisms in Kafka. That means more partitions, we may have more instances reading, more throughput, we need more partitions. If we add a new application, a new instance of the application A instance 4, this is not going to be able to read from Kafka because there are no partitions available. And that's one of the problems we have with Kafka. It's the teams, when they are designing how they are going to use Kafka, they have to choose the right number of partitions, and they need to understand how to figure out that number. And that's not easy. You need to have in account the throughput of the producers. You need to have in account how many instances you want to have. And also, it's not easy to scale, to add more partitions. That is possible. It has some problems you need to be aware of. And also, you cannot decrease the number of partitions. So if you increase the number of partitions because there is a peak in the traffic, you are not going to be able easily to decrease them later. So that's it. That makes Kafka a bit tricky for some teams. And you may think, okay, so if I cannot decrease the partition, just let go with a lot of partitions by default. But that's not a good idea either, because partitions also has a cost. There is a limited number of partitions you can have per broker and per cluster in total. Typically, more partitions means more problems because they require more coordination in the consumer side and in the broker side. So partitions are a very important concept in Kafka, and it's something teams using Kafka and teams managing Kafka need to agree on and be very, very conscious of what they are doing with them. So scale up, scale down the number of partitions is a challenge. And the other challenge is increase up or increase down the number of brokers. So if you need to put more brokers, it's something you can do. It's not very hard. But the thing is, those brokers initially are going to be empty. So you need to move manually or automatically with external service data partitions to those empty brokers to make them start to work for the producers and the consumers. So that's not something easy to do. It requires some manual actions and some time before they are productive. So if you are running hot in your brokers because they are consuming too much CPU or too much memory, add new brokers is not going to make the situation better right in the moment, because you need to do more actions. It happens the same if you want to decrease the number of brokers, you need to move all the partitions away from them before to scale down the number of brokers, and that also requires a lot of work. So that's some of the limitations Kafka has. are more oriented to scale up, scale down the service than any other thing. So let me back to the slides, see a better diagram of this, as I know I'm not the best one drawing, sorry about that. But the information is the same. We have producers, we send the brokers have the storage, and they internally, they use the concept of partitions, and the number of consumers are relational. So if you want to have more consumers, you need to increase the number of partitions, but you can decrease them. And also, if you want to add more brokers, you have to manually move some of those partitions to those new brokers to make them effective. There are some concepts more here which are interesting. Is the fact of if we put information in one broker and we lose that broker, we don't want to lose that information. For that, what we typically do in Kafka is to replicate that information to other brokers. So in this case, we have this partition leader free. What broker fee is going to do is to replicate that information to broker 2 is going to have a replica free, which is basically copy the same information we have in this partition to this one. If we lose the broker free for whatever reason, what consumer 1 is going to do is start reading from the replica, which will become the leader. This is how Kafka provides high availability and makes sure we don't lose data in any case. But that also, as you can see, increase a lot the number of partitions in the cluster. And as I said, the number of partitions you may have in a Kafka cluster is limited, so you cannot have infinite partitions. So this is Kafka, okay? Now, let's see how is Pulsar and how Pulsar solves some of those problems. So we start with exactly the same thing. We have our producer application sending data, in this case, to Pulsar. So Pulsar has exactly the same concept of brokers. So I'm going to have broker 0, broker 1, broker 2, and it's going to send data. It's exactly the same as with Kafka. So you can see they're not so different. We are sending data to all of them. As Kafka, Pulsar use Zookeeper for all the coordination between the brokers. So you can see we have also Zookeeper. So as you see, it's not so different. What is different is those brokers are not going to store that data internally. What they do is to send the data to a third system, which is called Bookkeeper. So we will have different instances of or nodes of Bookkeeper called bookies. So let me say bookie 1 and bookie 2. And what is going to do the Pulsar brokers, it send the data to those bookkeepers instead of store them internally. And this is the most important concept or difference between Kafka and Pulsar. Now our consumers can read from the brokers as they could do it in Kafka. That's not different, but you don't have to use partitions if you don't want. Okay, because the information is stored in the bookkeepers. If we need to scale up because we need to have more storage, we can just add a new empty bookkeeper here. And the brokers will start to publish information to that bookkeeper and to read information from that bookkeeper, but we don't have to move information between them. So scale the storage is much easier with Pulsar than it is with Kafka. Also, now our brokers are stateless. They are not storing any data. They are just receiving messages from the brokers and deciding where they're going, in what bookkeeper they're going to put them. And they are also receiving the request from the consumers to read the data. So they know to what bookkeeper they have to read from and then say to the consumers. That means if our brokers are running hot, we don't have enough CPU or enough memory, we can easily add more brokers, and they automatically will improve the situation. So if we have a peak in our traffic, we can just easily scale up the number of brokers, and once the peak is gone, we can scale down to save resources, to save money. For example, if we are in a cloud environment. So that's one of the main benefits of Pulsar, is the fact of the brokers are stateless, and we can scale up, scale down the brokers, and we can scale up, scale down the bookkeepers, the storage in an easier way, and we can also scale up, scale down the consumers because they don't have the limitations of partitions if we don't want to use them. In some cases, it makes sense to use partitions also in Pulsar, specifically when you have like high throughput requirements, but it's not mandatory as it is with Kafka. So those are the internal architecture of Pulsar and Kafka. The important thing here is that extra hop we have, or that extra component we have with Bookkeeper. So Kafka, we have only two components, the broker and Zookeeper, and the Kafka community is doing a lot of work to get rid of Zookeeper. So at this point, as experimental mode, you can already run Kafka without Zookeeper, and it will be generally available this year at some point. So right now we have just two components, but probably in the end of the year will be only one of them, the broker. That means we have less components, we have less network hops because we don't have that extra hop to the storage. It's the storage is always internal, and that may be important in terms of latency in some very specific use case, which very high requirements in terms of latency. And in general, the footprint is smaller. We don't need to have so many machines because it's just the brokers, and we only need to have expertise operating one system. In the other side, with Pulsar, we need to be able to operate the broker, Zookeeper, Bookkeeper. All of them are independent projects, slightly different. All of them are basically the GVM, but you need to be an expert in all of them, have the know-how to be able to operate them properly. But that also allows, give us some benefits. We have more flexible consumer patterns, so it's easier for the consumers. Or if we want to replace message queues with Pulsar, it's easier than with Kafka. It's easier to scale because we can scale up, scale down when required. We don't need to do any manual action or to do any external setup to be able to do that. And because of that, I would say it's also more Kubernetes friendly. You can use Kubernetes with, you can use Kafka over Kubernetes too, and there is a quite a mature operator to doing it, but Pulsar provides more benefits because that ability to scale up, scale down which is perfect for the Kubernetes world. As I said, consuming patterns, you have more consuming patterns in Pulsar than you have in Kafka. Basically, in Kafka, you have the shared and k-shared patterns. So basically, send every message to all the consumer instances available. It's like a round robin distribution of the messages. If it's k-shared, basically what you do is send always the message with a specific key to the same instant. That's important for ordering, so you know they're always ordered. But Pulsar also allows a couple of more consuming patterns like exclusive. So there is just one consumer or only one which can read from Pulsar, or failover. There is only one consumer reading from Pulsar, but if that consumer fails for whatever reason, then another consumer, V2 in this case, would take its place and will continually consume it. So in general, Pulsar has more flexibility from the consuming point of view. If you are looking to replace something like a message queue or have that type of requirements, Pulsar may be a bit more handy than Kafka in that particular case. Also, some interesting features when you are running this type of systems at scale, and which are quite different between Kafka and Pulsar. One of them is TLF storage. TLF storage is basically the ability to move some part of the data from the Kafka Pulsar storage to the cloud. So automatically move data to object storage like S3 in Amazon, like blob storage in Azure, like a Google Cloud Bucket, that type of thing. So what that means is you have infinite storage in Kafka and Pulsar because they are going to move data when needed to the cloud. This is very useful. It helps a lot in terms of capacity planning of the clusters and make the operation of Pulsar and Kafka easier. It's available in both of them, but in Kafka right now, it's a commercial feature. So the interface, it's part of the Apache core project, but the implementation right now, as far as I know, are only commercial. I know the community is working very hard to have open source implementations of it, and I think they will be ready, but at this point, they are not yet. In the case of Pulsar, it already supports theoretical storage with the main cloud providers, and they are open source. They're part of the Apache Software Foundation, part of the core of the project, so you can take advantage of them from the very beginning. It happens the same with, or similar with geo-replication. Geo-replication is the ability to replicate data between different Kafka or Pulsar clusters. There are several use cases for that, like reliability, high availability, or being able to organize your data in a very specific ways. In the case of Kafka, you can do it with an open source project called Mirror Maker 2, which is also part of the Kafka project, but it's kind of tricky. Mirror Maker is quite a low-level component, which basically move data between clusters. The setup is not easy, and the operation it's a bit challenging. Because of that, there are some commercial alternatives like replicator, multi-region clusters, or cluster linking, but all of them are commercial and they are not open source. In the case of Pulsar, that it's all of it's open source. It's part of the core project. There are different setups you can configure, like active standby, full mesh, edge, depending on what you want to do, and it's directly provided by the Pulsar community, so it's easier in that sense. Finally, Kafka is single tenant. That means if you have a cluster of Kafka and you want to split the information, the data in a specific way and isolate, for example, teams or departments, you can do that in Kafka, but using very low-level configurations like SLAs and quotas. In the case of Pulsar, it has the concept of namespaces, which is basically you can say, okay, this namespace is for this particular thing or this particular department, and they are going to be isolated to the rest of the company, something similar to the Kubernetes namespaces. And it's a pretty good feature to organize the traffic and the data in a specific way, making it easy for the teams to consume it or to produce to it. We have also the message side. I'd like to introduce this because it's something many teams ask me. It's a typical problem people have when using Kafka. The optimum size of a message in Kafka is 1 kilobyte. And you can, or we can put in Kafka messages until 1 megabyte. If you try to put a bigger than 1 megabyte message in Kafka, Kafka is not going to allow you to do it by default. You can change some configurations in the broker to allow that, but by default, it's just 1 megabyte. The reason is mainly because of performance. More than one megabyte, it starts to have some problems in terms of performance. So in the case of Pulsar, the limit is 5 megabytes. So it's a lot more. And most of the things don't need to go over 5 megabytes. So in this particular case, Pulsar makes it easier than Kafka. It's okay. You have one message from time to time, which is big, just to increase the configuration in Kafka or in Pulsar to send bigger messages. But if you need to send bigger messages all the time, or it happens often, then it's more problematic in Kafka. In Pulsar, there is a specific feature which allows to automatically split the messages in the producer and rebuild them or join them in the consumer. It may be handy in some cases when you know you're going to work all the time with big messages, but it has also some limitations. In general, if you need to work with big files in real time, in streaming, it's usually better to put them in an object storage like S3, Azure Blob Storage, and so on, and send a message with the URL so the consumer can then later download the payload from the object storage instead of putting it in Kafka or in Pulsar because of the performance considerations of those type of messages. Speaking about performance in general, well, there are a lot of benchmarks out there about what is more performant, if Pulsar or Kafka. My experience is Pulsar is slightly better than Kafka, but I never took the decision of choose one over another one because of performance. They are quite close to each other. And really, if performance is super important for you, the only way to decide is to run a benchmark with your data, specifically with your data to see what is going to be better. Even in that case, sometimes just slightly change a configuration in Pulsar of Kafka makes the result totally different. So in the end, what I recommend is don't put too much attention in performance when choosing between Pulsar and Kafka. Most of the time, it doesn't matter. Both of them provide a great performance compared with the other solutions we have in the market. So they are probably 95% of the cases will be more than okay with both of them. I'm working in New Relic where we have a lot of traffic every day, and I really don't think I will never take the decision to use one over another one because of the performance. I think things like operation, like the community, like have expertise in one of them are much more important than performance. Again, because they are so close. But depending on your use case, or you have things which are very critical in terms of latency, then the only way to know is test it by yourself and spend a lot of time doing the proper tuning to make sure you have the right results. Just to finish, community and licensing. I would say both communities are awesome. I have been participating in both of them for a while. They're really open. They are very friendly. I totally recommend both of them, but they are just in a different moment. Kafka is being used for a lot of companies. There are a lot of other companies providing services, support, Kafka as a service, all that type of things. So that means the Kafka community, it's a bit more professional, a bit more corporate than the Pulsar community right now. Pulsar community is all about being open, everything is open source. It's quite easy to make a question, have answer directly from the people working in the Pulsar project. If you go to the events, they are super technical. It's just in a different moment. Both communities are super nice, but depending if you look for something more mature, more enterprise, Kafka, it's the right way. If you look for something more open source, more collaborative, more technical, more that type of thing, then Pulsar is the way to go. I think it's just a matter of years. When Pulsar goes in adoption, we will see both communities will be more similar. Regarding licensing and open source, it's a bit the same thing. In general, Kafka, because have all those companies working on, there are more components which are not open source or are not part of the Apache project. So we saw some examples like the geo-replication, where those components are not available as part of the project. The Pulsar team, it's working a lot in adoption, so everything is there, everything is open source. You can use whatever component, and it's going to be provided not only in an open source way, but also as part of the core of the project, as part of the Apache Software Foundation. This is also important to understand. Kafka has it's more like a standard right now. So depending with what systems you want to integrate, those systems or those vendors may provide something which is only for Kafka and not for Pulsar. If you're thinking, for example, in monitoring, and have something which is able to provide all the monitoring out of the box, then there are more solutions in the Kafka space than in the Pulsar space. Also, if you think in connectors, like connectors for specific databases or services, then it happens a bit the same thing. Some vendors provide Kafka connectors, but they don't provide Pulsar connectors. One interesting thing is for Pulsar, there is kind of a proxy which is able to expose a Kafka API, compatible API. So you may have consumers or producers connecting to that proxy, and that proxy connecting to Pulsar, and those components are not aware of they are speaking to Kafka or Pulsar, because you have that process in the middle. So that may help with migration of systems, or when you have very particular use cases where you want to use Pulsar, but you need to have a Kafka API. So that would be handy. It was released last year. It's pretty new yet, but for many use cases can be used. So just a quick summary. I'm running out of time. The conclusions is both Kafka and Pulsar require know-how and experience with them. Many persons who are having problems with Kafka come to me, ask me if Pulsar is the solution. I don't think Pulsar is the solution in those cases. If you are having problems operating Kafka, you are going to have problems operating Pulsar because it's even a bit more complicated because there are more pieces involved. Both systems are critical. If you want to manage them by yourself, you need to have expertise and knowledge and put some effort to make it right, because there are also systems which, when they have problems, they typically create a huge incident in your service. If you are looking for something stable, heavily used for other companies, and with a very huge community, both open source and commercial, then Kafka is the right thing for you. If you are looking for something able to scale up, scale down, which has a lot of open source components and growing a lot, then Pulsar may be better. That depends a lot of what you are looking for. And that's all from me. Thank you very much for your time. I'm happy to answer any questions you may have, or if we don't have time for more, just feel free to ping me in Twitter. I will be more than happy to speak about this particular topic.
Hey, Anton, thank you very much. So we do have a question. Does the Confluent packaging of Kafka solve any of the limitations of Kafka that you describe?
Sorry, could you repeat the question?
Oh, yeah, sure. Does the Confluent packaging of Kafka solve any of the limitations of Kafka that you describe?
Um, I, Um, no, I don't think there is a easy way to solve any of these limitations. Most of them are part of the architecture of Kafka, so it's not an easy way to fix them. There are some improvements, some things you can do, which will help for sure. Have a proper team operating them will make things easier and have proper automation of everything. And yeah, now with the new version of Kafka without Zookeeper, some of those things will be easier, like the scale the partitions, and also with the TLF storage. So we are seeing a lot of improvements on this, but I think this yet too new, and we need to wait at least probably 1 year or a bit more to really see those problems solved. But yeah, for sure, Kafka is improving a lot, and the difference between both systems and the benefits are not going to be so clear in the future as they are now.